Okay. Now yesterday we have defined the potential energy of charge. So first of all we will again define it. That is define potential energy of charge Q, and from it define electric potential in electric field. So today our topic is to define electric potential in the electric field. First of all, potential energy of any charge is nothing but work done in bringing that charge Q from infinity to any point in the electric field. That work done is stored in the form of potential energy. Now when you are bringing the charge Q from infinity to a point in the electric field, say for example some electric field is produced by some charge configuration and you are bringing the charge from infinity to that point in the electric field, whatever is the work done, that is stored in the form of potential energy. Now we consider for general static configuration, that is done by some charge which is producing some electric field, then potential energy of the test charge, say for example you are taking test charge small q from one point to the other, then whatever is the work done in taking that charge q from one point to the other is nothing but the electric potential energy. Okay. Now, if you have say this charge q and there is an electric field, that is E, which is produced by some static charge configuration, then as you know that force is equal to Q into E. So this force is directly proportional to charge Q. More the charge which you are taking from one point to the other, then more the force will be. Okay. So this is the force which is acting on the charge Q when you are taking it from one point to the other. Now if this work done when you are taking the charge Q from one point to the other, whatever is the work done that you are having, if that work done is divided by this charge Q, then you will get work done in taking a unit charge. If you have this positive charge, then unit positive charge from one point to the other. So work done per unit test charge, work done per unit test charge, which is giving you the idea of electrostatic potential. So work done per unit test charge is nothing but the electric potential at that particular point. And this electric potential is independent of this charge Q. Say for example you are taking 100 coulomb charge, say Q is equal to 100 coulomb, and the charge is taken from one point to the other, whatever you are getting that work done, if you divide that work done by 100, then you get the work done to take unit positive charge from one point to the other. So here work done by the external force in bringing unit positive charge, say for example we have yesterday discuss this, that you are taking the charge is taken from point R to point P, then that work done WRP is equal to, what was that, UP minus UR, that is final potential energy minus initial potential energy. This is the work done. Now that work done is say divided by Q, the charge which you are taking, then you get Vp minus Vr, where Vp is nothing but potential at point P and Vr is the potential at point R. So this is the potential difference between point P and point R. So you are having now the actual value of potential but the potential difference is more physical significant quantity. Actually, potential at point P, potential at point R is not so significant, but difference of potential between point P and point R is of more significant. If you take this point R, that was our initial point, to be at very large distance, that is at infinity, then we can say that work done in bringing a unit positive charge from infinity to point P is nothing but electrostatic potential at that point. So we can say the electrostatic potential V at any point in a region with electrostatic field is the work done in bringing a unit positive charge. Now, unit positive charge, when you are bringing from infinity to a point P, then it must not have any acceleration. Okay, so that work done to bring that charge from infinity to a point P in the electrostatic field is nothing but the potential at that point. Okay, thank you.